Now we have already designed the mezzanine also, we have already designed the columns also. Now what we shall do is that we shall design the uh, anchor arrangement also for the base plate. So in the separate section we have discussed in very much detail about the anchor designing, that is how anchors are designed, what is the difference between mechanical and chemical anchors. So now in this lecture we shall learn that how we can design the anchor arrangement for this particular arrangement. So let us suppose that right now we want to design the anchors for this particular joint. So we can go to the display and force test diagram and support spring reactions. Let us say we want to check the forces for one time dead load plus 0.6 time live load, plus we can say uh, minus ELX and minus 0.3 ELY. So we can switch on the FX, FY and FZ, that is the horizontal and vertical reactions. MZ we can switch it off because that is a torsional moment. We can switch on the MX and MY. So we can left click on apply here. So here we can see that, and let us suppose if we're talking about the joint number 9. So we do have horizontal force of approximately 6.924 kilonewton. We can rationalize this also. So we can go to the show units form. And in here, if we're talking about the forces, we can say that we can reduce the decimal places to 0. Same shall be the case for the moment also. So we can reduce it to 0. We can left click on OK. So here we can see that approximately 7 kN force is the horizontal. And again 2 kN is the horizontal force along the other axis. And Fz is basically 163. That is the vertical force. And Mx is 5 and My is 14. But if we are talking about the external joints again, the forces are more or less same only. That is, in here it is 4 and 15, and here it is 6 and 16. And it is a little bit on the higher side at the, we can say, edges itself. Here it is 6 and 13, but in here it is 5 and 12 only. So what we can do is that we can again go to the display, show tables, and what we can do is that we can just simply select this particular node only. Just select this joint number 9 and display, press Ctrl and T option on our keyboard. So after that we can go to the joint output, and in here we can go to the reactions tab here. So we can left click on OK here. So this is basically the joint design reactions, and this is basically the joint reactions. So we can go while selecting the output case, we can only switch on the we can say load combination, and we can switch off the single load cases. So press control option while selecting the multiple, we can say options here, and click on apply multiple items filter. And in here we can see that now these are the horizontal reactions that we are having for this particular unique name 9 and label number 5. So these are all the what we can say as the output load reaction. So we can go to the file, export current table to Excel. So now these are the reactions that have been exported. What we can do is that we can just simply reduce the decimals here. We don't need to have that much numbers here. So after that, these are the MX horizontal and bending moments. MZ we don't need to worry about, but we can keep it as of 0. And these are the horizontal reactions, and this is basically the vertical reaction. Now the thing is that what we need to do here is that we do need to multiply all of these values with -1. So what we can do is that because this is basically the reaction, so we do need to tell the Profis software, that is anchor design software, that what exactly is the force. So we can left click on insert here, and we can simply put a formula here, that is the cell is equal to this into -1. So we can 1 2 3 4 5 and 6, and we can simply stretch these values here, and we can again decrease the decimal values. So now what we can do is that we can just simply delete these values here, and we can just simply copy paste these values here. Now we can open the Profis software. We can open the basic default option of and we can say anchoring to concrete, and in here at the bottom you shall see that we do have these what we can say as the force and the moments here. So either we can import the custom factored load, or we can simply select on import factored loads from the spreadsheet. So we can just left click here and then simply press Ctrl and V option on a keyboard. So here we can see that automatically all the reactions have been copied from the Excel file, including the name of the load combination also. So this shall help us a lot in, we can say, reducing our working time. So we can left click on apply here. So automatically with this process, we can ensure that all the load combinations shall be designed by the software itself. So what we need to here as the next step is that we do need to go to this uh, anchor plate calculation tab. Yeah, this particular option. So we do need to switch off the anchor plate rigidity check, and we do need to assume that the anchor plate is rigid in itself. And then after that, we can just switch on the cases where there is a, we can say, a little bit of bending moment also. So here we can see that 49 kN is the axial load and 5 kN is the bending moment that is coming. So what is usually done is that in this kind of system is that this whole system is usually anchored on the RCC grade slab itself, which thickness is in between the 200 to 250 mm. So what we do need to do here as the next step is that we do need to check the grade of the concrete here. We can assume that it is a normal concrete, and it is up to us that whether we do need to assume that it is a cracked or uncracked concrete. If the bending moment is quite less and the flexural strength of the concrete is higher than the bending moment that is coming, we can assume it as the uncracked. Otherwise we can assume it as the cracked concrete also. After that, on the next step, we can select the anchors here also. So let us say if we are talking about the uh, anchor. So for in as a first trial, we can select the mechanical anchor here, and we can select HST4R as the stud anchor. So still here you can see that in some of the cases the ratio is higher than the allowed. Let us just allow the software to check. And then after that, as a next step, we can select the user selected embedment depth here. And by selecting the 120 mm, we can check the utilization in all the cases here. So here you can see that in majority of the cases, by selecting the 120 mm bed bend depth, the anchors are passing in the design with the maximum ratios of, we can say, 89%. And wherever we are having the show warnings in here, basically there is no as such bending moment that is coming, and there is only axial load, because ultimately that is the gravity load itself. So in the absence of any kind of bending moment at the base, obviously the anchors cannot be designed. So ultimately what we can conclude here is that by selecting the HST4R M12 anchors of 120 mm bedband depth, the system is safe for all kind of loadings. And there is, like, you can do the further optimization also. Like instead of 120 mm, we can check that whether the system is passing with 100 mm depth or not. So here we can see that with 100 mm also, it is more or less safe in the design. And we can reduce the diameter also to check that whether M10 anchors are also okay or not. So here you can see that now the ratios are increasing. So M10 is not safe, but M12 it should be safe for all the load combinations here. For further optimization, we can check instead of 100 mm whether the system is safe with 90 mm depth also or not. This is the embedment depth, that is the depth of the anchor inside the concrete. So here also we can see that the anchor is passing with 90 mm depth also. So what we do need to do here is that we do need to change the profile also, the profile of the box section here. So in our system, we have taken the box section of 150 by 150. So instead of rectangular hollow section, we can take circular hollow section. So the profile that we have taken is 125 by 125. So what we can do here is that we can click on 20 by 20 by 1.6. and select 125 by 125 by 6 section here. So we can see here that after selecting 125 by 125 by 6 section, the anchor arrangement is passing in the design. So that is how we can check the anchor design calculations for different sizes of the members, for different base plate sizes, for different anchor sizes, and for the different specification that whether the concrete that we are handling is cracked or uncracked. Similarly, let us say if we want to go for the chemical anchors also, so instead of the mechanical, we just need to check for the adhesive anchors. And as I said that the anchor that is easily available in Australia is basically HIT HY 200 RV3 plus HAS. So we can select this particular anchor here, and we can just check with the depth that is required. So we can again click on the calculate option, and here we can see that it is a little bit failing in the design. So what we can do is that we can let the software to calculate the embedment depth here, or we can enter the embedment depth manually also. So instead of 75, let us say we proceed with 150 mm. So with 150 mm also it is facing an issue. So we can increase the diameter also here. So by increasing the diameter to M16 and keeping the embedment depth as 150 mm, we can see here that ratio is approximately near to the 83%. So this is how we can instead of the mechanical, if we require, we can proceed with the chemical anchors also, that is with the HIT HY 200 RV3 and HAS A4M16 chemical. So that is a basic criteria to calculate the anchor design, and for the we can say mezzanine platforms, either by keeping the we can say as the mechanical anchors or chemical anchors.